Hi, good day to you, and welcome to my channel where I tutor you in science for free. The topic in this video will be
speed of reaction. So once you hear the word speed or rate or things like that, first thing you need to think of is a stopwatch. Or like in the earlier videos of this chemistry section, you'll be thinking of different tools to measure time, and one of the favorite ones, of course, posting YouTube videos I like is video. And in the real science world, a lot of videoing is actually employed to help time and record experiments, but for secondary level, stopwatch is sufficient. So there are two ways to see how fast things are going, either by the rate of how fast the reactants disappear or how fast the products appear. So if your products, one of your products produced contains a gas, what you can do is to use a gas syringe and a stopwatch to measure how fast the gaseous product is being produced. And of course, the setup will look like that. And because gaseous products will escape the system, you can also measure the change in mass. You have to use an electronic scale and a stopwatch to make this happen. And so logically speaking, if you are looking at the rate of how products disappear, the graph will look like that against time. And if you're looking at the rate of how products appear or produce, the graph will look like that against time. And for faster reactions, it will look like that. And slower reactions, it will look like that, with all the other parameters staying the same, like concentration, mass, pressure, things like that. So pretty simple, straightforward way of dealing with how you obtain measurements and results regarding speed of reaction. So next, let's talk about what factors affect the speed of reaction. Before we dive into that, because we are talking about reaction, and based on the previous video about the energy changes, we know that there are certain levels of energy that is being held in chemical bonds, and it takes some energy to break them and to form new ones. What we are interested here is effective collisions. So atoms and molecules bounce against each other all the time, but not all of them will result in a reaction. Sometimes they just bounce very lightly. They don't have enough energy to exchange bonds. Therefore, no reaction occurs. So what we are looking at is energy greater or equal to activation energy to initiate a chemical reaction. So the four factors that you'll need to understand will be concentration of reactants. So concentration being the nature of how much an item is dissolved in how much an amount of water, and that will be in mole per dm cube usually. So the higher the concentration, then there are more reactants bouncing around with each other, bumping into each other. So that will increase the chance of effective collisions. So increasing concentration will increase the rate of reaction. Pressure of reaction. So when you hear this word pressure, it will only concern gaseous reactants most of the time. Okay, so at higher pressure, you're pressing gas reactants to hang around with each other at a smaller space. So the chance of them bumping into each other as an effective collision will be higher. So increasing pressure will increase the rate of reaction for gas products. Particle size, next one. Particle size, this concerns the surface area that is being exposed to the system. So it's a great example will be if you cut ingredients into smaller pieces, they cook faster because there's more surface area to absorb the heat energy to be cooked. If you try to dissolve rock sugar versus powdered sugar, the powdered sugar will dissolve a lot faster than the rock sugar because the particle size are so small. They interact with water molecules a lot better. So decreasing particle size will increase the rate of reaction. So this will concern solid reactants. And lastly will be temperature. And temperature of the system, if you increase it, will give energy towards the reactants, the particles. They move at higher speeds with more force. So as they bump around each other, the probability of having an effective collision is definitely increased. So increasing temperature will increase rate of reaction. And one more concept of this rate of reaction will be the use of catalysts. So catalysts, they will come from the transition elements over here. in the periodic table, the middle portion, they contain a lot of extra empty electron clouds to allow temporary bonds to be formed with them. Then they will form with the other intended reactant. So this provides an alternative pathway of reaction with lower activation energy. So catalysts will speed up the rate of reaction without itself being chemically changed. And for catalyzed reaction, the amount of reactants and products will remain the same, just that it's faster and lower activation energy.
And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe and share it with somebody who needs to see this. And I will catch you in the next video. Bye!